Everyone, today we're looking at problem 994, rawing oranges. So given an m times n grid where each cell can have one of the three values, 0 representing an empty cell, 1 representing a fresh orange, or 2 representing a raw and orange, we're essentially looking for the minimum number of minutes that must elapse until no cell has a fresh orange. And if this is impossible, just return -1. So the keyword here is minimum number of minutes, which means we will be using BFS. So let's go and implement this. The first thing we want to do is obtain the rows and columns. We also want to keep track of the fresh number of oranges and have a queue where we'll be appending all the current raw and oranges. So we're going to iterate through the rows and columns so we can append all the current raw and oranges and all the fresh oranges. We need to keep track of this in order to implement our BFS. So if it's 2, that means that the orange is rotten, so we'll append that to our queue. And if it's 1, that means it's fresh, so we'll have a counter for that. We also want to have a counter for our result, which will currently be 0. And now all we need to do is just implement the BFS algorithm. So what we want to do is make sure we're iterating as long as we have fresh oranges and rotten oranges. Otherwise, there's no point in iterating. So now we're just iterating through the queue, which is like the current number of oranges that are rotten, and looking at its adjacent directions to see if there are any fresh oranges. So we'll be using a for loop for this. So here I'm just looking at all possible directions. Now we also need to keep track of the boundaries. We don't want to be, we want to make sure we're within the boundaries. So we need to check if rows in between 0 and less than rows. And we want to check that column is greater than or equal to 0 and less than columns. And that row and column and grid row and column is equal to 1. We want to make sure it's a fresh orange that we're looking at to turn it into a rotten orange. And yeah, so if it's a fresh orange and it's within boundaries, we turn it into a rotten orange and we append it to our queue. So we can look at all the adjacent oranges now for that fresh orange, which is now a rotten orange. So we can continue updating the fresh oranges. And here we're keeping track of all the fresh oranges as well. That's because if, let's say, these 3 oranges were rotten, but there's no adjacent there's no oranges here and there's one orange here, then that would mean that there's still one orange left, so we need to keep track of the oranges, because if there's one orange left, then we just return -1, since we couldn't turn all the oranges into raw oranges. And then here outside of this for loop, we're going to increase our result, and then we're almost done. We just return basically if return result if fresh is greater than 0, else we just return -1. Yeah, so the gimme comp, so oh yeah. Oh my bad. Okay, so I think we're missing is greater than 0, else -1. Let me check what we're missing. Grid DQ. Let me just, fresh is greater than 0. Oh, my bad. So if fresh is greater than 0, we're supposed to return -1, and then else just return result. Yeah, so that works. Yeah, so that's all for this problem.